from this point to this point, it's within 0.00002. Okay? From here to here. Okay? Very flat, or flat. So we know that it's flat. The other thing we have to look at is the grinding wheel. And the grinding wheel has to be dressed. Just like we dressed the pedestal grinding wheel, we have to dress this. And the way we're going to do that is by using a diamond. Single point diamond. Little single point diamond. Yeah. That's a diamond in there. That's a diamond. You can see it. That's a diamond.
Sounds right like a diamond.
Yeah. Diamond is one of the hardest materials known to man. Where's your part? Get your part and bring it over here. We're ready. Now, this cable is called a chuck. So it's a magnetic chuck. So now when I turn the lever, it holds it. It holds it. Now, what I need to do is I need to make sure that that diamond is right in about the center of that wheel. In order to accomplish that, there's a marking right here. It shows you where the center is, approximately. And I'm going to put that approximately in the center, and I'm going to kick it off to the left just a little bit. And then I'm going to lock this down so it doesn't move. Okay. I am then going to position this so it's directly beneath the wheel, just like that. Now I want you all to take a look at this, okay? Take a look at it. Oh, just go ahead, put it over here. Everybody take a look at that. Take a look at it. It's pretty much on the center of the wheel, off to the left just a little bit. Now the reason it's off a little bit on the left is because of the wheel rotation. The wheel rotation, as you can see by the arrow here, is going like so. Okay? So if I was to have this not locked, and the wheel was to catch this, and this wasn't locked, then it would just push it up. However, if I'm over here and the wheel catches it, can you see what would happen? It would go, right? It would crunch the bed, okay? That's the reason that happens. Next thing is you always want to make sure you turn the wheel by hand to see if it's cracked or if there's any kind of damage to it. Once that happens, then we go ahead and turn it on. Now, it's kind of like a milling machine in a way. You've got a lever over here, which controls the head movement up and down. You've got a converse over here, which controls in and out. And then a table movement, once I loosen this, will go back and forth. Okay? What I'm interested in doing right now is this coming down, and what I want to do is I want to just make sure that I'm going to dress the wheel, and I'm going to take about 1 to 2 thousandths off. I'm just going to touch very lightly, and I'm going to go straight across this way, straight across, back this way, okay? And I'm going to set my head to 0. Now this dial over here is incremented in tenths of 1,000ths. That means each line is a tenth of a thousandth. Come over here and take a look. You can see the 0, and you can see the increment. Go ahead, everybody take a look at that. Surface grinding is a finishing operation. A finishing operation, it's typically not a metal removal operation. It's a finishing operation. You typically surface grind materials that are very hard. However, it can be used in materials that are soft as well. But it's for making things very, very precise in terms of size and finish. So how much do you take off? You take off 1,000ths, and go across. Take off another thou, come back across, and you look at the wheel. And what you want to see in the wheel is you don't want to see any dark spots in the wheel. You want it clean all the way across. And you want it flat. Now, there's a difference on how fast you move it going across. If I go real fast, I'm going to make that wheel act coarse because it's just going to do this all the way across the wheel. So the wheel is going to be like that. It's going to have like ridges, okay? If I go across real slow, the wheel will be very smooth and very flat as well. And I typically go about medium. Okay? There's reasons why you do one and you do the other. If you go across very slow, it makes a very smooth finish on it, and the wheel will give you a better finish on your part. However, it won't last as long. If you go across fast, it'll make the wheel act as a roughing wheel, and it will go across and give you perhaps a worse finish, but it will last a lot longer and it will run a lot cooler. I go be a medium because we're just going to be taking off. Maximum depth of cut on a grinder is 1 thou. 1 thou. Okay? Okay, so I'm done. I want you to take a look at the wheel at the end over here and see that it's nice and flat. Take a look at the wheel, look at the end of the wheel. Don't touch it, watch the grind. You can see that it's been dressed properly. Been dressed properly. Now, because it's flat, and it's been dressed properly, we're going to be able now go ahead, and I'm going to stop the machine by hitting the button. Not the E-stop, the stop button. Yes, you could use the E-stop, but don't. The reason being is people like to smash that E-stop and then it breaks. And then it's like, I gotta fix it, right? So I gotta go to the store, go get one of these bad boys, and spend my time, make sure it works. Okay, wait till the wheel stops completely. Move the dresser, the single point dresser, away from the wheel. We're going to wait until the wheel stops. Do not reach in there while the wheel is turning. You'll grind your knuckles to your fingers. Okay? So always wait, and wait until the wheel stops. Now in the industry, that might be a little different. They might tell you to move the wheel or the table over to one side and then grab it. Okay? That's their safety precautions. At this school, we wait until the wheel stops. Once you're doing that, you go ahead, you can remove that. You wipe the chuck, the magnet chuck, and then you take your hand and you wipe it with your hand to get that last bit of dust. Your hand has enough laminate on it to actually attract all the dust. Then we have the part that we're going to grind. Go ahead and bring me apart. Right. Now we have this part here, and we have set the part and clamped it to an angle plate to grind it exactly 30 degrees. And I don't know if it's exactly 30 degrees, if he's cut it exactly 30 degrees or what, but we're going to find out. So now we got that. What we're going to do here, we're going to raise the wheel up. Alrighty. And what I do is I typically, like so, put it up against the fence over here. I lock it, check it to make sure it's tight. And now I can bring her in. And I can start in on here. Now, you've milled this, but I don't know if it's actually high over here or high over here. I have no idea of knowing this. So you have to kind of figure this out. So I'm going to come up over here. I'm going to turn on the wheel. And I'm going to try to touch on this corner over here. Okay? I'm just going to try to touch. A little bit on that corner. Okay? Now I'm going to come in real carefully. And we're going to be able to see this. Yeah, I'm coming down really slow. If you get eye level, you can see where you're about to touch, by the way. Everybody see that? Okay, good. Move it out of the way. Now I'm going to put my 0. I've got my 0. Okay? Got my 0. Tighten it up. Now, I touch there. I'm going to touch, go across over here, lock it up. I'm going to come in and see where I'm at. Ooh. That's my high point right there. I just barely nicked it over here, and now that's my high point. So I'm going to drop this by, I'm going to drop it by about 2 thou. Still there. Drop it by a total of 5. Drop it by 10. Drop it by 15 now. Okay, so 15, it's not touching. There's 10 or 15 thousandths there. Okay. So, as I can see, and as I go across, I'm going to start running. I'm going about a quarter turn, and I'm going to go straight across like that, back and forth, until the wheel comes off. And as you can see, it's touching one end, and I'm now going to just go ahead. I'm going to 0 that out because that's where it's touched. And again, how much did I say I could take off? 1,000, step the cut. 15. Everybody wants to be a comedian. Alrighty, here we go. So again, I go up and back, and I turn this in about 1 turn. And remember, I'm going across the entire length of the part. So come over here. I want everybody to take a look at the part. You'll notice that the part over here is part of the ground, and it hasn't touched over here. Alrighty? Okay, so everybody take a look at that. Everybody. Everybody see that? Okay, so now we gotta go each time we go down, we're going to take 1,000 and go back across. A little more. I'm taking a total of 5 now. Take a little more. And I told you I was about 15 off. And right now, I'm at 7. I'm going relatively fast. But what I want you to notice is I told you it was off 15, right? So it was 0 and 15 high, right? And now I'm around 7 off. And you'll notice that the grind is about halfway. Put a little marker. It's about halfway. Take a look at it. It's about halfway there. Anybody see that? By the time I get down to 0, I should be there. Now, Victor, how much was it at the 3-inch mark? 3-inch? 10,000?
Yeah, little down here.
3-inch 10,000. Okay, so what we're talking about is the critical dimension. The critical dimension will be the angle and this dimension right here, which needs to measure 3-inch exactly. We have milled it, he has milled it, to 3-inch 10,000ths here. Okay? That's what he's milled it at. So we're going to continue on our merry journey here. And we are going to take another 1 thou. Coming up on 10,000ths here. Now you can all see that the surface finish is pretty darn good actually on this, and that's a 32. It's not a bad surface finish, and you can tell that the surface finish between the grinding and the mill is significantly different. And you'd say, well, why don't we just grind everything? Some people would argue that. Well, you can't take as much as it takes you longer. That's what. Again, 1,000ths at a time. All right. Here we go. I'm going really fast here, so I'm hogging on off. And another little time or so. Okay, so the motion I'm using is up and back, turn in. Up and back, turn in. Up and back, turn in. Now, even now I've taken a ready cut, I want you to notice something. I've already taken a cut. She's saying, Mr. Manon, it's still giving me a little bit of spark there. That means it must be material. That's true. Just like there's deflection in a cutting tool, there'll be deflection in the part and the wheel. Okay? According to this measurement here, and again, this is just a rough measurement, by the time I hit my 15 mark, I should be pretty darn close to almost cleaning this whole thing up. But I think I'm gonna miss my mark a little bit. Because here's 15, and you'll see that I'm not quite clean. Close, but I'm not quite clean. And as you can see, come over here, and you can take a look. I'm not quite clean in that corner. Okay? Over here, take a look at this little corner. I'm not quite there yet. Come here. Hold on. You can take a look at it. And you can see that I'm off maybe 1/1000th or so. Maybe 2. Okay, but I'm still going to be on that length. At the lowest, I'm still going to be 3 inches, 10/1000ths too big. Okay? Take a good look at that. 3 to 4 inch micrometer. Okay? I'm going to show you what we're going to use that for. Okay? And I'm going to take a few more thou, maybe 2 more, just to make sure that we clean it up. And I'm going to take one more out of this. Now I'm going to go back, take a spring cut. Take another spring cut, go backwards. And as you can see, at this point, it's going to be pretty exact in terms of my 30-degree angle and my length. But I don't know if I have that 3 inch 10, so I'm going to go ahead, I'm going to stop my wheel. And I'm just going to very lightly bring it out over here. Okay? Wait till my wheel stops. Don't break down your setup. You don't have to break down your, you don't have to take the bar off. You can slide it off to one side. And we can take this and we can measure it right here. Okay, and I'm going to show you that. But you got to wait until the wheel stops. What did I say?
335.
That's right. Good. We'll make sure. Somebody going, oh, you never told me that. Yeah, I did. Okay. And again, you may have to take it off when you do this, but don't take it over there. Just, right here is fine. I'll show you a hot ticket to do this. Okay. And again, wait until the wheel has stopped. Very important. Okay, the wheel has stopped. I've demagnetized, and I can bring it over here. Okay. And I can now mic this right here exactly. Yeah. And I can exactly, because I took a little bit off that end, didn't I? Took a little bit. And he says 3 inch, 10 thou, right? All right. So, now I'll tell you what. Let me see if I can put that on there and make it stay. for you guys. Looks pretty. That looks good. All right, so go ahead, don't touch it. Take a look at the measurement and tell me what you think the measurement is. Take a look at that measurement. Now we're measuring it at about a 60-degree angle, right? So it's not a direct 1-to-1 ratio. It's going to be an angular measurement, right? So if I take off 1/1000 off the top, what's that going to reflect at a 60-degree angle? Yeah, it's going to be something like 86%, something like that. If I want 1/1000 and I go down 1/1000 on the 30 degrees, it will actually give me more, right? So I've gone down a little bit more. Yeah. Who can tell me what the actual measurement is?
Let's see it.
Anybody? It's a 3 to 4 inch micrometer. And you're almost down to 0.
3 to 4 inches.
So I'll give you the first number. The first number is 3 inch point something. 3 inch point what? What's reading on the thimble?
0.5.
5,000. So it's 3 inch 5,000. So how much do I have to go? 5,000. Okay? Now, knowing that it's 3 inch 5,000, am I within tolerance? Yeah. I'm done. No, you're within tolerance. If your part is within tolerance, do not try to make it perfect. Because I'm going to tell you what's going to happen here as well as in industry. You're going to mess it up. Then your boss is going to say, well, was it in tolerance before? Yeah, but I tried to make it perfect. You go. Not only did you scrap a part, but you wasted time. The reason they give you a tolerance is so that you don't have to waste time on trying to make it perfect. So if you try to make it perfect and you waste time and you scrap the part, you have a double whammy there, right? It's a double whammy against you. It really is. Okay, so at this point, I am done. Okay? I am done. Now, you will notice on the part, there is a burr, right? Because when you grind, there's a burr over here, very sharp burr. And don't do this with your finger because you will slice it. It's that razor sharp. Take a stone. You got stones in there. You just come along and just hit it with the stone. See that? See that? That just takes that burr all the way off. Now you can slide your finger across. Now I'm going to leave it like that. I want you to just feel this one over here and just gently feel this one over here. Go ahead, feel both sides. Don't slice your finger on that second side. I had that happen. You got sharp, right?
My whole Scare me? You okay, buddy? I'm scared. Good
Everybody see the difference there? Right? Everybody see the difference? There's a difference. One side's okay, the other side's not. Now when you burr apart, make sure you can burn it in its entirety, right? Not only on the side, but on the end as well. Because you will get knocked off with this little burr on the end. And this is the perfect place to do it because it's magnetized, it's not going anywhere. And you can, go very carefully. Do this whole side. Again, be very careful. You can do it all. And I'm not gonna do it all, Victor, you're gonna do some of it. Okay?
No, keep going.
You wanna make sure, though, at the top, it's got no burrs on it, and when you look at that, that's a good, it's a pretty darn good finish. Okay? And that's how you grind. Okay, that's all there is to it. How long did that take me?
Like 20 minutes.
10 minutes? 20 minutes? No, I don't think 20.
Oh, when to stop it? Oh,
It took me about 10 minutes, right?
We'll have to check the edits.
I don't know. I got the peanut gallery over here. All right. All right. Let me see. Now, you guys have to have questions, right? What type of wheel is this? It's a surface grinding wheel. Yeah, I know it's a surface grinding wheel. It's an aluminum oxide wheel. Okay, that's what is used for steels. Aluminum oxide. Now, some of the wheels over here, you'll see they're green. That's called a green wheel or a silicon carbide. And that's made for grinding carbide. And you'll see another one that is really thin. In fact, it's almost non-existent. That's a diamond wheel, again, for grinding carbide. Okay? But the white ones that you see here and the ones on the tensile grinder, those are aluminum oxide wheels made for grinding steel. Yes, sir.
So I haven't got to this yet, obviously, but if his angle or how he has that mounted
Yeah.
makes a difference of what you were just saying, 15 thousandths difference.
Yeah.
How did he set that up to make sure that?
With a sign bar. Remember the sign bar? Okay, so he set it up with a sign bar, and we know it is. Now, how did he mill it? How did he mill it so that it was approximately that? So, what he did is, you notice there's two holes here, right? Well, they're 1/4-inch ring holes. And he put two pins, put a pin in that way, a pin in that way, and then he set it on top of his mill vise. And he tightened it. Right? And then he took an end mill and cut across. Okay, so just pretend there's a pin going through here, and it sets right on top of your mill vise. And you tighten it with the vise. Pinch it. And so now these holes, because they're parallel, right? But here comes the kicker, right? What happens if your holes are not exactly parallel?
You're out.
Now, I hate to say this, but your holes are on about 15 thousandths on one side. Okay? But that's just to get you roughly there. That's why I have you grind it, is to make it exactly. Because the whole purpose of this little tool is so that you have exactly 30 degrees here. People go, oh, but that's important that the holes be, well, yeah, it's important, but you're not going to use the holes. Why are the holes there? To hang it on the wall or hang it in your toolbox. That's what the holes are for.
Decorative.
Decorative, right? Lightweight, you know. But what is really accurate is this. This now, right here, is exactly 30 degrees. And if you've made this 90 degrees, which we know we have because we milled it, just like you milled the vice stop, right?
30, 60, 90.
This would be 30, this would be 90, and if this is exactly 30 and this is exactly 90, what does this one have to be?
30, 60, 90.
90, 60, 30, which one? 60.
60.
The sum of all triangles, okay, another rule of thumb, the sum of all triangles has got to equal 180. The sum of all triangles, the sum of this one, and this one all add together, we got to add up to 180 in a triangle. That's just the rule, okay? No discussion here, that's it. If it doesn't add up, then it's not a triangle. Okay? So if I know this is 90 and I know that this is 30, how do you know this is 60? Well, by math, right? I add 30 plus 90, I get 120. If I subtract that from 180, this becomes 60. Okay? That's the way it goes. Okay? By default. So that's why I have you run it. And when he checks this on the optical comparator, he's going to see it's perfect. perfect. Okay? All right. Any questions? All right, that's it.